Hello, and welcome to another episode of Maths in an Empty Classroom with me, Mr. Southern. This video is on sketching quartics, and I'm just going to be taking you through two examples of how to sketch quartic graphs, which is new to the new A-level spec. So, here we have our first example, y equals x minus 1 all squared, x minus 3 all squared. I just want to talk briefly about the basic shape of a quartic graph. Y equals x to the power of 4. The original shape of this, if I just sketch it out on an axis quickly, looks like so. Y equals x to the power of 4. And that's because for any negative x values, when you raise them to the power of 4, you're going to get a positive in the same way as when you square. And the graph is symmetrical about the y-axis. Now when you start to develop the complexity a little bit, so if you have x cubed term, x squared term, what your quartic can end up looking like is something like this. So we have, because it's x to the power of 4, we have a maximum of 4 roots, 4 intersections with the x-axis, and we have a maximum of 3 turning points. And what we have to do is we have to look at the form of the equation, work out the roots, and work out how to sketch the graph from there. So, if you look at this equation here, y equals x minus 1 all squared, x minus 3 all squared, you can see that you're going to have 1, 0 as one of the x-intercepts, and 3, 0 as another x-intercept, but both these are going to be repeated because of the squared. So we have a repeated root at 1, 0, and we have a repeated root at 3, 0. As always with all graphs, if you make x equals 0 to find the y-intercept, from the first bracket you would have negative 1 all squared, and from the second bracket you would have negative 3 all squared. So it's going to be positive 1 multiplied by positive 9, so it's going to give me a y-coordinate of 9 and 0, 9 as my intercept. So let's draw out a set of axes and just think about how this function is going to behave. So I've got a y-intercept at 0, 9, which I'll put there. I've got a repeated root at 1, 0 and a repeated root at 3, 0. So in the same way as with the cubic, when we had a repeated root, it touched the axis. That is going to happen here and again here with this kind of shape. So we're going to go down through y is 9, repeated root here, back up, back down, repeated root there, and back up like so. So 1, 0 as a repeated root there, 3, 0 as a repeated root there, and 0, 9 as the y-intercept, x-axis, y-axis, and that's job done for that. Okay. Second example then, we've got y equals x, x plus 2 all squared, 3 minus x. So, I'm going to identify the roots to start with. From the first one, we're going to get 0, 0, where x is 0. We're going to get negative 2, 0 from the second bracket, but note that it's squared, means that one is going to be repeated. And then the final root of this quartic is going to be 3, 0, because x would have to be 3 to make that bracket equal 0. Now, a couple of things to think about. The y-intercept. I'm not going to worry about finding the y-intercept here because I've already done it. It's going to be the origin. If I made x 0, y would be 0. That's done already. But before we start thinking about the sketch, let's just consider the shape. We've got a negative x here, which means if we were to expand out all these brackets, the x to the power 4 term would be negative. So what that means is that rather than in the previous example, where we had a quartic that looked like so, we're going to have that reflected in the x-axis, so it's going to look more like that. Okay. So let's draw a set of axes, put on the important points, and draw the graph from there. Okay, so we've got negative 2, 0 as a repeated root, 0, 0, and 3, 0, and it's going to look like so. So we've got it being a negative quartic, it's going to go up, bounce here, back up through there, and back down through there. So repeated route here, back up, and like so. So as you can see, 1, 2, 3 turning points, that's the maximum. 3 points of intersection with the x-axis, that's 4 solutions, 1 repeated. So we have negative 2, 0 here, 0, 0, that's the origin, and 3, 0 there. X-axis, y-axis, and that's sketching quartics. Job done.